In this video, we're going to look at piecewise functions. A piecewise function is defined differently for different parts of its domain. And we're going to break this down and make it into something understandable by looking at a very straightforward example involving movie ticket prices, because you all understand this. So movie ticket prices are often defined differently for different age groups. So we're going to let age be our independent variable x, and price depends on age, so that is our dependent variable y. So the function for the movie ticket prices that assigns different values, different ticket values, depending on your age x, is defined by this. If x is between 0 and 12, if that's your age, you pay $5. If you're between ages 13 and 54, you pay $9. Or if you're 55 or older, you pay $6.50. So we're going to graph that over here. Okay. So we need to come up with, let's see, a way to break down this x-axis that will take us from 0 to 55. So if I do 5s, that'd have 10, 20, 30, 40, 50. That'll be perfect. So we're going to go by 5s. We're going to call that 10 years, 20, 30, 40, 50, and 60. And we won't mark the important ages just yet. So the price is just between 0 and 10. We'll just go by 1. So 1, 2, 3, 4. There's a price of 5. That would be $6.50 right there. And 7, 8, 9. And this is in dollars. Okay. So if your age is between 0 and 12, you pay $5. Okay. It's assuming they charge infants, which they don't, but that's okay. We'll be theoretical here. So you pay $5 all the way up through the age of 12. Now you have to remember age is a continuous variable, and this variable really starts the moment you're born. Okay, and it continues until you die. So, but the point is, it continues. There's a continuous area between the ages of 0 and 1. There's a continuous little short piece of the x-axis here that's for ages between the day you turn 12 and the day you turn 13. So 12 and a half would be halfway between 12 and 13. So the question is, how much would you pay if you are, say, 12 and a half? And you're still considered 12 in our society. Okay, so you would still pay $5 all the way right up until you're, let's see, 12 years old and 364 days old. You still get to pay $5. But the day you turn 13, then you pay $9. So to graph this, you're actually going to pay 5, 5, 5, 5, 5, all the way out to 13. I'm going to put an open circle at 13. Okay, and at that moment, your price jumps up to 9. So you pay $9 all the way out to not just 54, but actually all the way out to 54 years and 364 days, or right up to 55. Then the day you turn 55, you get to pay less, $6.50. So this is a piecewise function, and this is its graph. Okay, notice how it has different parts to it. So for different parts of its domain in there, oops, I drew that at the wrong part, didn't I? 55 is there. Okay, going back. So for different parts of its domain, for the domain between 0 and 13, it's defined by this. For this part of the domain, it's defined by this. And for this part of the domain, it's defined by this. It's defined differently. Okay, let's actually write this as a function just for practice here. So as a function rule, we'll just call it f of x. You always start with a big open brace, and I'm making it big enough to put 3 lines because I have 3 parts of my domain. and you say what y is equal to. Remember, y equals f of x. So if the price is 5, we would say f of x equals simply 5. You can say for, or if, or just put a comma. But for x values between 0 and 12. So for 0 less than or equal to x, I'm going to put, well, here's a little confusing point, which I mentioned up here. You actually don't put 12 because we're going all the way right up to 13. So if it's strictly less than 13, right up to that moment you turn 13, you pay 5. Then y is defined as 9 for the next section if you are equal to 13 years old, all the way up to, let's see, 55, and then strictly less than there, and then when you turn 55 you pay 650 or 6.5, same thing, for x greater than or equal to 55. That's how you would write it in function notation. Here's another piecewise function shown in function notation. So let's practice evaluating f of x with this example here. So we're going to find f of negative 5, f of 0, and f of 5. So to find f of negative 5, what we do is we look for which part of the domain we're in first, because y depends on where that x falls. So let's see, my first section says y is 3x plus 8 if x is less than or equal to negative 3. Well, negative 5 is less than negative 3, so that's the part I'm going to use. The function definition we'll use is 3x plus 8. So 3 times negative 5 plus 8, which comes to, let's see, negative 15 plus 8 is negative 7. Next is f of 0. Well, 0 is not less than negative 3, so we're not using the first line. The next section says f of x equals negative 2x if x is between negative 3 and 1, which 0 is. So here f is defined by negative 2 times 0, which is 0. And lastly, f of 5, you can see the pattern here. Okay, it says on the bottom one, f of x equals x squared minus 3 if x is greater than or equal to 1, which 5 is greater than or equal to 1. So y is defined by x squared minus 3, so 5 squared minus 3, that's 22. And let's also look at absolute value as a piecewise function. I love this. This is just kind of a fun thing to do. So the absolute value function makes any number positive. All right, absolute value of 3 is 3, or absolute value of negative 3 is also 3. Okay, and the x, or the input, equals itself if the number is positive, and it equals the opposite of itself. You make it positive if it's negative. So let's actually graph it first. And the absolute value of 0 is 0. That is defined. If x is a half, y is a half. If x is 1, y is 1. If x is 2, y is 2. If x is 3 and a half, y is 3 and a half. Okay, it's just a straight line where y equals x. The output is the same as the input. Okay. Over here it's a little different. So when x is negative 1, y is defined as positive 1. When x is negative 2, 2, negative 3, 3. Okay. Y is actually defined as the negative of the x input. A little strange, but if you look at this, the negative of negative 3 is positive 3. So what you're doing here is you're taking the negative of this input, okay, because the negative of a negative is positive. And that's the equation of this line with slope negative 1 that goes through 0, 0. Okay, so to write this as a piecewise function, well, it's different depending on if x is positive, so if x is greater than or equal to 0, or if x is less than 0. And it doesn't really matter if you put the equal to sign here or here, it just can't go in both places. So if x is greater than or equal to 0, that's these positive numbers, y is defined by x. Or if you have a negative number, if x is less than 0, y is defined by negative x. And let me write out two examples here. Let's just do f of 3. Well, 3 is greater than or equal to 0, so y is defined by x itself, which is 3. Or let's do f of negative 3. Negative 3 is less than 0, so if I plug that in here, I have the negative of x, the negative of negative 3, or positive 3. So this is how you break it down to absolute value as a piecewise function. And that's it for this video on piecewise functions.